Okay, I know these two topics are very much review, so we are going to just do a super quick overview of them and just make sure you're remembering the formulas and how to do them and whatever. I probably could skip this day, but we are going to take the time and just make sure you guys are all okay. So, midpoint and distance formula. Of course, midpoint is kind of like an average of two coordinates. Um, it allows you to basically take your two x coordinates, divide them in half, figure out your new x coordinate, your two y coordinates, add them together, divide them in half, figure out your new y coordinate. So basically you're finding the average of your coordinates when you're finding the midpoint, or the center, or the halfway point between two coordinates. And of course the distance formula measures a distance. Okay? All right, here is a problem. It says a landscape design includes two square flower beds and a sprinkler that's halfway between them. Find the coordinates of the sprinkler if the centers of the flower beds are at 4, 5, and 14, 16. So I graphed them here. Clearly the center of the sprinkler then will be somewhere kind of around in here, and I'm just estimating that. But we need to figure out where the sprinkler head will be located. So you have two formulas to work with, midpoint and distance. If you're trying to figure out the halfway point between those two flower beds, then you're going to need to use the midpoint formula. So you can label this as like your x1, this is your y1, this as your x2, this is your y2. You could certainly have them switched around as well. But then of course you're going to use the midpoint formula, which is this one right here. And basically, again, all that does is it finds your average of your x's and your average of your y's. So when I average my x's together, I will have 4 plus 14 over 2. And when I average my y's together, I will have 5 plus 16 divided by 2. Okay? And so then 14 plus 4 is 18 divided by 2 is 9. And 5 plus 16 is 21 divided by 2 would be 11.5. And if we look back at our graph, let's just kind of look if I estimated okay. 9 and 11.5, I did pretty good. It probably should be up just a little bit more, but that's about where it would be. Okay? All right, then just simple, if you want to find the distance between these two, again, you can label this as x1, y1, x2, y2. Probably the hardest part of these is having to simplify the radicals, but you can handle that. Okay, so here we go. Difference in your x's squared. So 4 minus negative 3 squared plus negative 4 minus 6 squared, which of course when you go boom boom, that's 7 squared. And then negative 4 minus 6, of course, is negative 10 squared. So we'll have the square root of 49 plus 100, which of course is the square root of 149. Then you always want to look at, can you break that down? Like if it was the square root of 50, that would break down into root 25 times root 2, which of course would break down into 5 root 2. You cannot break the square root of 149 down, so we will just leave it like that. All right, then the next one. On a straight road, George is 3 kilometers east of a water tower. So George is 3 kilometers this way. And I'm going to say G for George. Don is 6 kilometers west of the water tower. So Don is 6 kilometers this way, and I'm going to say D for Don. Relative to the water tower, where is the midpoint positions of George and Don? Well, clearly, that total distance is 9 kilometers, and I'm ignoring the water tower in there right now. I know the total distance is 9 kilometers, so I know that the halfway point, half of 9 is 4.5, so I know the halfway point will be 4.5 kilometers from either end. So 4.5 kilometers this way, or 4.5 kilometers this way, and this is not to scale, so I apologize. But the midpoint, of course, is going to be somewhere in here. Okay, so if you go 4.5 kilometers from Don's position, that means you're still 1.5 kilometers west of the water tower. So that's what you need to know. Oops, 1.5 kilometers I want to say, west of the water tower. Okay, and that's how that will look. All right, so then we have one more problem here. We have Ruby, who is 15 miles east of Lila. All right, so I have Ruby right here. I'm going to say that that's an R. She is 15 miles east of Lila. So Lila's right here, and it's 15 miles from here to here. Okay. Then We have Mary, who is 16 miles left or west of Lucy, and Ruby is 12 miles east of Mary. How far is Lila from Lucy? Okay, so it's a little bit tricky to figure out, but we have Mary, who is 16 miles west of Lucy, and it doesn't really say where Lucy is. And Ruby is 12 miles east of Mary. How many miles is Lila from Lucy? Okay, so here's what this is going to look at. Something like this. We have Mary, again, who is 16 miles east of Lucy. So let's call this Mary. And we have Lucy down here, okay? This is 16 miles. Ruby is 12 miles east of Mary. So this distance right here between Ruby and Mary is 12 miles, okay? This is not to scale, again, and I apologize. So, but we can make this work. So, from here to here, it's 15, okay? So now I want you to think about this. If this is 16 from here to here, and this is 12, then this has to be 4 miles, of course. And of course, we know it's 15 from here to here, okay? And it's 12 from here to here. So we know that this distance then is 3 miles. Okay, so now the question becomes, how many miles is Lila from Lucy? And this is Lucy over here, and this is Lila. I have two L's, so I shouldn't have used L and L. But how far is Lila from Lucy? So Lila is these 3 miles here, plus these 12 miles here, plus these 4 miles here. So 3 plus 12 is 15, plus 4 would be 19 miles. Okay, and that will do it for you.